we are going to finish off implicit differentiation today. I'm hoping to spend maybe just about half the time on this, and then we can spend the rest of our time maybe, going over any last minute topics or ideas that you want for your midterm. So the last thing we want to work on here is, how do you find the equation of a tangent line for an implicit curve? So the one I'll choose to show you how that method works is 13. And the implicit curve is that guy. And we're being asked to find the equation of the tangent line to this curve at that point. So first thing I'm going to do, step 1, is I'm going to find the derivative. And we know that to get that guy, we have to do a fair amount of work. So here goes. I guess I should write that down again. Right, you differentiate x squared with respect to x, you get 2x. Negatives cause problems, they cause problems because either you lose a negative or you gain one, you get it all mixed up. So you can tackle this 2 different ways. This is a product, so it's going to be f and g, and it's subtracted. So one way around that problem is to kind of just do the product rule inside some brackets, like that. And let's finish this guy at the end. If you differentiate that guy, you get negative 2y. Again, remember to finish with a dy by dx. And if you differentiate that guy, you get 0. So what we have is 2x, take away, and now you can forget about the negative and just focus on the xy. So it's 1 times y plus x times 1 dy by dx. Take away 2y, dy by dx, and then it's going to equal 0. And now I can subtract all the stuff. So it's going to be 2x, take away y, take away an x, dy by dx, take away 2y, dy by dx, and the whole thing's going to equal 0. Now, there is an alternate way to tackling this negative xy. I could have called x, I'll say it again. I could have called the f negative x and the g just y, and that would have taken care of this as well. So whatever it is, whatever of those 2 that you decide, that's fine. Right, at this point here, don't we have to figure out how to solve for dy by dx, right? So as long as you do it to both sides, it's okay, rule. Tell me what I can do to both sides. Remember, our goal is to solve for dy by dx eventually.
You move both the dy and the x's over to the right side.
Oh, yeah, I wasn't thinking of doing it that way, but there's nothing wrong with that. So I'm going to add an x dy by dx. I'm going to add a 2y dy by dx. I like your way better than the way I was about to do it, because I'm just a creature of habit. I was just going to get rid of these 2 over here, and same answer, so it wouldn't matter. Okay, good start. What do you do next?
Factor out the dy over dx's.
And that leaves me with an x add 2y. And they'll divide by the ugly guy. So we have 2x minus y over x plus 2y. And we've got our derivative. And that's step 1. Now, to find the equation of a tangent line, the second step is you find the slope of the tangent line. And you do that by evaluating the derivative at whatever the point happens to be, in this case, at 5, 3. So the derivative is 2x take away y over x plus 2y. The value of the derivative at the point that we're interested, 5, 3, is 2 lots of 5 take away 3, and 5 add 2 lots of 3. And that's 7, and that's 11. So the slope of the tangent line is 7/11. And the last step is that you use what's called the point slope equation. To get the equation of the tangent line. So it's going to be y take away 3 equals 7/11 x take away 5. And that guy distributes, not very pretty answer. Add 3 to both sides. Well, adding 3 is like adding 33 of these, so that leaves you with 2. So there is your equation of a tangent line. Does that seem pretty straightforward? A lot of what you do is typically the same thing, right? Don't you find the derivative of the implicit curve? Then you evaluate it at the point that you're trying to get the tangent line, in this case at the point 5, 3. That means x is 5 and y is 3. You get the answer to the slope. And then you'll use the point slope equation, same equation each time, and you get the equation of your tangent line. Any issues with that, or that seem pretty straightforward? No problems. Okay, let me, hopefully I've got this set up right, and I do. Are you looking at Desmos right now? Great. So I am going to put in, hopefully it's going to work, x squared take away xy take away y squared, and I'm going to make it equal 1. Yay! There you go. Implicit curve, right? Desmos does implicit curves for you. I'm also going to put in the equation of the tangent line. Now, if this works, shouldn't this line I'm about to draw, which looks like it's going to be blue in color, shouldn't it be a tangent line at the point 5, 3? So let's find the point 5, 3, which is there, right? You see that guy? So when I draw this line, don't I want a tangent line to virtually be on top of that line, right? Nice tangent line guy. So provided I didn't screw up in my math, which has been known to happen. Oh, am I good or am I good? Would you agree it's a tangent line? Now, suppose I had screwed up. Suppose I got a sign wrong, which is very easy to do. Can you see that that line isn't a tangent line at 2, 5 anymore? Do you see it misses it? This is the right answer again, right? Tangent line. Suppose I got this guy wrong, right? Maybe I got a sign wrong over here. Would you agree that's definitely not a tangent line at 5, 3? So if you were doing a test question like this, couldn't you use Desmos as a good check? Hey, I got it right. I don't need to worry about it. Or how come it ain't working? Oh, I got a plus, so it should be a minus, right? At least it gives you a chance to check it. So that would be one of the uses that you could take that to. Right, let's return back to doing another example, I think. Some implicit curves have names. I'm going to write this down, and then I'm going to try and pronounce it. There is an implicit curve with this equation, and this is a family of curves, and these are called I know how you say that word. It's Eudoxus. He's a Greek mathematician I know of. I'm going to murder this word. How about compile? Anybody want to have another shot at it? I'm just trying to pronounce it. Okay, this curve is called the compile of Eudoxus. Eudoxus is a very, like Archimedes, Pythagoras, right? Ancient Greek mathematician, very, very clever guy. And we're being asked to find the equation of this implicit curve at the point -1, 2. Okay, let's see what that looks like. Y squared is that guy. Step 1 would be to differentiate it. Okay, what do you get if you differentiate y squared with respect to x?
Two y times dy dx.
Really isn't the most important thing to remember, and if you do that, you'll probably never get them wrong, is that when it's got a y in it, don't you always finish with a dy by dx? That's the key. Now, that guy there is multiply by the power, reduce it by 1, and this guy is basically power. So not the ugliest differentiation to do. Okay, what do I do now to solve for dy by dx? Pretty much not a lot to do here. So what do I do next?
Divide by 2y.
It's probably not a big aim for this question. It really doesn't matter. But couldn't I do a little style point on it by, factoring out a 2 and cancelling it? But that answer will do fine. So step 2 now is find the slope of the tangent line. And you do that by evaluating the derivative at this point here. So it's going to be 20 lots of -1 cubed, take away 2 lots of -1, and I'm using this guy up here, over 2 lots of 2. So that's -20 plus 2, so that's -18, and this, I believe, is 4, and that becomes -9/2. And then point slope equation, and we're done. So it's going to be y take away 2. Slope is -9/2. X take away -1. Essentially, you add 1. Distribute with the 9/2. Since I'm running short of room, add 2 to both sides. Well, adding 2 is like adding 4/2. And there you're done. And I could, but I don't have time. Couldn't I plug that into Desmos and do that? And shouldn't we get a really nice tangent line at -1, 2? And we'd be really happy because we got it right. So if I gave you an implicit curve and asked you to find the equation of the tangent line at 1, 3, do you feel comfortable about how you would do it? Find the derivative, evaluate the derivative at the given point, and then use the point slope equation, right? So step 1, 2, 3. As long as you know how to do the derivative, won't the other bits kind of follow? Okay, well, that's a little bit quicker. If that's good, do you need to see another one, or are we good? We're good, okay. Well, we are pretty much finished, ready for the midterm. Has anyone got any topics that they want me to go over, something they'd like me to address? Any questions? Pretty open-ended now. No questions yet? Harvin, what's your question? It looks like you're going to ask. Okay.
Not really.
Okay.
Just, for some reason, it just does that. It'll like spike up.
Okay, so it wasn't you talking. That's fine. Give me a few seconds. I've actually written the thing, and just want to double check something. I don't want to say it and then on the day it ends up not being true. So hopefully you can't see this. I should have checked that before I did this, but okay, we're good. Okay, so your midterm is, well, let's do the obvious. It's on Monday, and it's going to take place at what time does it start?
7 a.m., right?
So set your alarm early, easy to forget. Do you use our class Zoom link, or is there a special link for the midterm?
Different link.
And where will you find it?
It's on Canvas, right?
Right. So remember that, because I don't want you to get up, hit the class link, and then wonder where everyone's gone, right? It wouldn't end well. Your midterm is going to be in chronological order. There's going to be 2 sections. Section 1 is going to be the multiple choice. There's going to be 10 of those questions. And a multiple choice question, for the most part, should be done really quickly. So if it's going to take you more than about 3 minutes to do it, you're doing it wrong. So just pick the letter C and move on. Now, for the multiple choice questions, I do not want to see any working. So all you will write down is question 1 is A, and question 2 is D, and question 3 I don't know, so I'll guess C, and so on, right? And then 10 questions from section 2. And the section 2 questions are the ones I do want to see the working, and they will be in chronological order. So the last question you'll see in the multiple choice will be an implicit differentiation question. The last question you will see in section 2 will be an implicit differentiation question. The first questions you will see are from week 1. So you remember doing the limit as x tends to 2 of x squared minus 4 over x plus 2, that kind of thing, right? So as you go through the 10 questions, you kind of will see, you know, like the weeks travel on. So obviously after or just before the implicit differentiation question, won't there be a chain rule question? And then before that, won't there be a product and quotient rule question? And then before that, there'll be a polynomial question. And before that, there'll be a, well, what would be before that? Find f dashed of a using the formula question. And then before that, there'll be limits. And before that, there would be estimating using numerical techniques, right? So kind of traveling back in time. But that's what you're going to be seeing. Any questions about anything that I've said?
All right, so you said there's going to be 10 questions for each section?
No. Some questions will be ABCs in them, and you might only get one question. Some questions, some sections might have, they're going to probably be a lot more questions asking you to differentiate things. Right.
Also, like in section 2, you said there's going to be 10 questions, or?
Yes, 10 and 10.
Yeah. Okay,
So,
yeah, that's...
Someone in the chat asked the question, so let's see. Can we go over the f dashed of using the formula question, for example? Okay. We have 2 questions that involve the, if I'm picking up the question correctly, Product rule, well, I have got to remember that I keep changing here. Product rule, question rule. If you want to find the derivative of this figure, product rule is f dashed g plus f of g dashed, right? You're going to have to remember these formulas, or you're going to have to write them down somewhere. And I can guarantee you're going to get a product rule, like I can guarantee you're going to get a quotient rule. I mean, they're too big, right? You're going to get a chain rule, right? Again, pretty obvious. You're going to get an implicit one, right? But main themes, you're going to get it.
I think he was asking for the the equations, like it was like f of x minus h of x over x minus h.
Not a problem. Well, let's just finish this guy off there. Okay, so there are two f dashed of a questions, right? How to get the derivative using limits. One of them is the limit as h tends to 0 of f of ah, take away f of a over h. And the other way that you can get a derivative by using limits, is the limit as x tends to a of f of x take away f of a over x minus a. Does that ring bells now? You remember those guys? They're horrible and they take a while and there's a lot of algebra in them, right? The x tends to a version, this one here, works well when it's square roots and fractions. And if it's like polynomials, you're at x squareds and x cubes, this works well. Technically, you can use either, but if you want to make your life simple, use that one for, you know, quadratics and use this one for fractions and square roots. Now, is that all the person wanted to know, or did they want me to actually do an example using this method? So if you want to type it in, because evidently your mic's not working. Gotcha, will do. So let's take an example of, I would like to get the square root of 4x plus 1, right? And I want to find the general one, which is the harder one to do, which is I want to find f dashed of a. Hold on a minute, I'm moving screens around. Here we go. So I'm going to use this formula. So it's going to be the limit as x tends to a of f of x take away f of a all over x take away a. Then what I'm going to do is I'm going to replace f of x with this guy. And f of a is basically that guy with the x's replaced by an a. And the bottom doesn't change in these questions. Now you're going to have some ugly fraction to deal with. It has a special name that starts with the letter C. What method do we use to solve these kind of fraction limits? And if you can't remember the name, can you remember what special version of one I use?
Can't you multiply by the top expression with the sign change?
Yep.
I don't know the name though.
In a way, I guess the name's not that vital. It's called the conjugate method. Right. That mess there, by the way, says 4x plus 1. So we have the limit as x tends to a. On the bottom, I have x minus a, and I have the square root of 4x plus 1 added to the square root of 4a plus 1. And this guy could be multiplied. And if you multiply these together, you get 4x plus 1 The two guys in the middle disappear, and then you get take away this guy times this, you get 4a plus 1. So the shortcut for multiplying this guy by his positive version is that it's the first guy squared, take away the second guy squared. But if you want to do a FOIL and check all the terms, that's okay. It works too. Now notice it's take away everything. So that's 4x, add 1, take away 4a, take away 1. Don't really do anything to the bottom, except can, just keep writing it down. Now in this case, typically you'd expect this to happen. There's some bits that cancel each other out. Now we're getting close to the end. If you do the thing correctly, there is going to be some cancelling, with someone on the top cancelling out someone on the bottom. And in this particular question, it might not look like that's going to happen, but you have to, bear with it. It is going to happen. Is there another way you can write 4x take away 4a?
4 times x minus a.
Now, if you write it like that, so I'm going to have to make this go away. Can you see that you can now get a cancel? This x minus a cancels out this x minus a. That will leave you with the limit as x tends to a of just a 4. And on the bottom, a kind of ugly looking combination of square roots. And that's good. Because once you've done the cancelling and wrote down what's left, the limit gets finished by simply just replacing the x with an a. Right? You won't need to do any more. It's basically like substitution, right? Brute force. So I have 4 over, well, 4x becomes 4a plus 1, or plus another square root of 4a plus 1. And you're always looking for style points, making things look nicer. This ugly square root is the same as this ugly square root. So actually, don't you just have 2 of them then? So you can combine them by saying I have 2 ugly square roots. 99% finished here. What's still to be done?
Make it 2 over the square root. Yes.
That's it. Just cancel out a little bit. And you are finished. The derivative of a would be that guy. That's a pretty major topic, so don't be surprised if you get a question that asks you to find f dash of a, or it might say find f dash of 4, which is essentially the same question. The only difference is that there's going to be a 4 here, so that would be 17. Any other topic or question that you'd like, example you'd like me to do? Let me do something for you. How would you differentiate secant tan x? What method would you use?
The product rule.
Okay, so make this f and make this g. So if this was a test question, actually just writing that one line down has got you a point. Because what you're telling me is that you know the correct method to do that. Now, Wouldn't normally write this at the side, but this one, I think, deserves it. What is the derivative of secant x?
Secant x times tan x.
Now, if you've got a good memory, you just know that. So there's the derivative, there's a g, plus, well, secant x. Here is the second problem. Don't we need to find the derivative of tan x?
Secant squared.
You are on a roll here. Or you've got it in front of you, which is still okay. Oh, you are on a roll here. See how easy it is if you just remember certain derivatives. Isn't that the best way to do it? If you write them down, that's a kind of, it'll work, but it's just so much easier. Right? If you just know the derivative. Now, if you rewrite these guys and tidy it up a little bit, we now come to the second phase of every derivative question. And that is style points. A lot of people say, hey, I've got the derivative, I'm good, I'm off to the next question. No. Finding the derivative is very important, but equally important is style points. Even if it's minor, it needs to be done. Is there any improvement that you can do to this expression?
Vector out of secant.
That looks like it's an identity, but it's not. So that's you finished. But sometimes couldn't that be sine squared plus cos squared? In which case you'd replace it by 1, right? Or it could be cos squared, take away sine squared, in which case you'd replace it by the cosine of 2x. Or it could be, well, I can't think of any other stuff in mind, but it could be an identity of some other type, like sine x over cosine x, and you'd call it tan x, right? There are going to be situations where this will be something better. But in this case, we're finished. So as you're going through this question, yeah, there's a fair number of points for this. There's going to be a fair number of points for that. You're only going to get 1 for that because that's just a formula, but you're going to get a lot more for doing this. You're going to get bits for knowing these. So you can, there are lots of places where you can get points. One of the reasons I ask you to show working is that if you made a mistake anywhere in this process, if I can see the process, then I can give you partial credit for doing it right. Making this up. But let's suppose you didn't know what the derivative of secant x is and you forgot to write it down. Or you thought it was, I don't know, cosecant x, cotangent x, right? You thought it was something else. So you would write down what you thought the answer was here, right? But everything you did was correct, except this derivative was wrong. You don't get 0 points, because isn't the only thing you did was one piece of the puzzle wrong, right? The whole structure was right. All the other bits of the puzzle were right. What you did with them was right. Just one piece is wrong. If I can see it, I can give you points for it. So, okay, that would probably cost you about 20%. So if the whole thing is worth 10, you get 8 out of 10, right? Because the rest was right. So in homework, we cut a lot of corners for very sensible reasons. Homework takes a long time, so you don't write every line of work in. You know, that would take too long. You'd skip lines, you know, you do things. You just read the answer off instead of writing it down. Totally understandable. But will you try and get into the mindset that when you do the midterm, if you don't write it down, I don't know what you were doing, and I need to see what you're doing in case it's wrong, right? So I need to see the working. I need to see, oh, you thought the derivative was this. You thought the derivative of was that, right? Try and think of it in this kind of that way, so that if you do make a mistake, I can give you partial credit. Any other topics? Time management then. 2 hours is a long time. You'll be surprised how quickly it passes. So when you're doing your questions, I've already mentioned it, but I'll say it again. If it takes you more than 3 minutes to do the multiple choice, you're doing it wrong. Pick C or whatever letter of the alphabet is your lucky letter and move on. When you're in section 2, if you know you're going to have a problem with a particular question, you might say, I'm not good at chain rules. They're always a pain. I'm never quite sure what to do. Leave that darn question to the end. Right? Just forget about it until you need to. Right? And there might be a couple of questions like that. Try and organize your time so that you don't spend 20 minutes on one question, right? And, cause yourself a whole load of grief. Okay. I'm about to call it quits today because you've got 10 minutes to start getting ready for your midterm. I hope you use it wisely. I'll hang about for any questions. Make sure you put your last name down. And bye-bye. And I will see you at 7 a.m. on Monday. Bright and cheerful and ready to, what's that? Kick butt and take names, right? So you're going to murder this exam. You're going to kick it around and hit it with things. Okay. Anybody got some questions?
Yeah, I actually just remembered I had a question on implicit actuation. I just wanted to know how to exactly see when to put in the d of y over d of x, because I know some of my problems in WebAssign have had y's in them, but they didn't have the dy over dx, which is a little bit strange.
I'm trying to think of any implicit that won't have a dy by dx in it, because that's kind of part and parcel. The original question one, right? The original questions don't have dy by dx's in it, right?
Yeah.
But the answer will have, because the answer will have a dy by dx equals ugly fraction, because that's what they end up looking like. So I'm trying to think of what you're getting at. Have you got an example of a question where that happened? Maybe that would help me understand what to do.
I'm looking real quick.
Sure.
Okay, never mind. It was just product rule that I didn't see quite well.
Okay. Yeah. So if you were doing a product rule, let's put that guy there, for instance, call this F, call this G. The product rule would be F dash G plus F of G dashed. If you differentiate an X, it's always what you would have got. So the derivative of X is just 1. If you're not doing anything to it, it's still Y cubed. You're not doing anything to that guy, it's still X. And if you differentiate a guy with a Y in it, in this case, Y cubed, it's the usual, in this case, power rule. And then you remember to finish with the dy by dx. That's the key to differentiation, is that when it's X's, the answer is just what it always was. But when it's y's, it's almost the same thing, but you always finish with a dy by dx. Essentially, you're doing a chain rule. This is like your inside function. So something cubed, 3 something squared, times the derivative of the inside function. So if you're wondering where the dy by dx comes from, it's really because of the chain rule.
Thank you.
You're welcome. Any other questions?
Yeah, I had a question
Mhm.
about the homework.
Not a problem. What you got?
So in the implicit, what's it called?
Implicit differentiation.
Implicit differentiation. Yeah, thanks. I had a question about 12.
12. Okay, let me find you. Can you read it to me, or shall I go looking?
Yeah, I can read it. So it's use implicit differentiation to find y prime,
Mhm.
and it's x to the 2/3 plus y to the 2/3 equals 4. And so I found
Okay.
that. Then you need to find the equation of the line tangent to the given
Okay,
curve.
at what point?
So is at -3 times the square root of 3, comma 1.
-3 square root of 3, comma 1, right? Okay.
Yeah.
So we'll start with the derivative then. Multiply by the power, reduce it by 1. Multiply by the power, reduce it by 1, but remember to finish with a dy by dx. And equals, well, derivative of that is 0. So I'm going to have this guy, take that away from both sides. And then divide. And it's really just a really, really ugly fractional power thing going on here. So let's try and make it a little bit simpler. The 2/3 cancel out. So I now have this weird looking fraction. Well, still points. I guess I could leave it as -1/3, but really I don't like negative powers. Are you okay with the negatives becoming positives and the guy in the top goes to the bottom and the guy in the bottom comes to the top? And that's just going to be a little bit easier, I think, to deal with.
Mhm.
Now, we are interested in evaluating this derivative at this rather ugly coordinate. And so it's going to be -1 to the power of the third over -3 root 3 to the power of the third. Okay, 1 to the power of the third is just 1, so that wasn't too bad. I'm going to rewrite this guy as -3 to the power of 3/2. Because that's a half power and that's a full 1 power. 1.5 gets me 3/2. Now, the reason I'm doing that is so that I can figure out what to do with this guy to a third. Because if I don't, it's going to be really ugly looking. And basically what you get is, well, can I pull out another negative while we're at it? So I'll take it really slowly. And that gets me, well, I'll do it next line. The thing essentially ends up being that. The negative cancels. 3/2 raised to the power of a third. You multiply the powers together, gives me a half. A half power is the square root, 1 over root 3. So the derivative has now gave me the slope of the tangent line. And I'm going to be looking at that point. And so it's going to be y take away 1 equals the slope, that's m. X take away that is adding it. distribute this fella, and this guy times this guy actually comes out quite nice. And then you add 1 to both sides. So what could have been a really, really ugly answer ends up being relatively nice.
All right, thank you. So I did have a question about one other thing.
Sure, what you got?
So, on the practice midterm,
Yes.
so in question 11,
Is it something you can read out to me, or will I have to go look?
yeah, so it's the position of a particle is given by the formula st equals 1/4 cosine times 2 pi t. But my question is
One
mostly just, it
cosine.
seems too
Is it-
early to do like the chain rule on that.
Oh, well, sometimes I might put questions in the wrong place. Are you saying it's 1/4 cosine of 2 pi t? Is that what you said?
Yes.
Okay, so. Well, if you want to get its velocity, don't you just differentiate it? And if it's kind of early on, I guess I put it in the wrong spot, but the question's still good. So it
Yeah.
is a chain rule. That's the only way you could do this.
Okay.
So if you differentiate a cosine, you get a negative sign. And then don't you finish with the derivative of the inside function, which is essentially 2 pi. And if you cancel them down a little bit, you get negative pi over 2, the sine of 2 pi over t. And if you want the velocity, you're finished. And if you want the acceleration, don't you just differentiate that one more time? That makes sense?
Yeah.
Okay.
All right, thank you.
Anyone else got a question?